Hello everyone, welcome to Cassini-craft. Another video about our target. This is Saturn. The beautiful rings. Deep down is the Voyager. Here is some moons. Calidus. Titan must be someplace here. And now we're gonna compare the size of it. Compare the size of Venus, Earth. Look at this. It's different type. This is rock, terrestrial. This is gas. Different radius. Saturn is very bigger than the Earth, so the gravity is different. So the calculus is different. The constants, orbital mechanic calculus is different here. We have to put it in mind. It's the Sun and Mars, you know. Now we're gonna use something very interesting about this eyes on the solar system. Is the telescope mode, and we're gonna put it on all right, here. Okay, we can see the orbits of the moons, you know, another planets, Jupiter, and this is the Sun. This is the ice of the inside the ring, and our spacecraft, Cassini 2.0, we're gonna be something like this, a moon, looking by this position of Saturn. Orbiting it. However, must be very calculated to not fall into this huge gravity, and the spacecraft will just crash. Have to be the right precision of the speed, orbital speed. And now we're gonna watch the magnetic field. This is the magnetic field of Saturn. What is important for us? Because when the spacecraft be orbiting the planet, it must be send signals to the Earth, you know. However, these signals can be tarnished by this huge magnetic field. So it must be created some kind of chemistry environment to protect the processor, the memory, and the electronics hardware to make the precisely signal, you know, to not be tarnished by this huge magnetic field. And last but not least, the minor moons. This is something that Cassini 1 brings to us. Now we're gonna try to see the minor moons. Look at this beauty. Each little line, it's an object. It can be a moon, it can be a asteroid, it can be rocket, ice, it can be everything. It can be even a planet, small planets, orbiting Saturn gravity. Very beautiful, each line. And we can do something better here. It's just to go to system. We can see the magnitude of so much moves. This is the Sun. And look at this. This is a real time. They are very small, very, you know, we can speed it at the time. The time here is very, and just pass through, for example, 1 week, 3 weeks per second. Each second, it's 3 weeks. So if you see all planets keep orbiting and all these little points keep orbiting the planet. 2 months by second. And if you see Saturn, it's orbiting the sun, and a lot of little things are orbiting it. Let's go back to time. And well, last but not least, I am doing a comparative. Let's show the solar probe. This is the solar probe Parker, the last NASA spacecraft. It's orbiting the sun. Very speed, very high temperatures, you know. Orbit, it's very close to the sun and just very distant after that. I just take some pictures of it. This is the pictures, and I use the tool to comparative. This is the carbono shield protecting the spacecraft. This is the design of it, 3-dimension model. This is the solar panel. And this is comparative with another telescopes and another spacecrafts. The Hubble, the length of each one, different perspectives. This is the James Webb origami golden scales. This is the background of it, protecting to the sun, and this is captured the biggest of the beginning of the galaxy formations by the infravermelho. This is a comparative with the burst. We take in mind what is the size of a spacecraft. It's a Juno, very beautiful spacecraft. The design must be very clean. This is the Voyager 1. So, is this with everything today? I hope you enjoy. Follow the channel, make the like and comment, and let's give it a best shot. And God bless America.